All right, hello everyone. So we're going to go through B. So question 13, 70 marks, answer all three questions. In his book, The Art of the Programming, now remember you're going to be given options here. No options, you have to answer them all, but you'll be given options. Okay. In his book, as far as we know, in his book, The Art of Computing, Donald Knuth states that searching is the most time-consuming part of any program, and the substitution of a good search method for a bad one often leads to substantial increase in method. The Python code below shows the implementation of a search algorithm. It doesn't tell you which one. Examine the code and answer the questions that follow. Okay, so simple enough as a thing to be looked at. So let's have a look at the code. You got names, you got a list, and those lists contains strings. Name equals input, look up a name. Okay, found equals false. That's your boolean. You're setting your variable to be false. Index equals 0. You're setting another index to be 0. While not found. Okay, and index not equal to the length of the names. If name is equal to the name's index, so found equals true, that means it'll change the boolean, okay, and kick it out. Else index increase 1. In other words, go check the next one. So let's try and figure out, state the name of the above search algorithm. So I suppose that's the first thing. What search algorithm checks, and if it's not it, moves to the next one and just checks. And then if it's not that, it moves to the next one and it checks. Well, that algorithm is going to be linear search, isn't it? A linear search algorithm. That's what that's going to be. Simple enough. Okay. What type of data is variable found? Well, found is false. So I've already mentioned it's a Boolean, isn't it? Boolean only has two states, true or false, 1 or 0, yes or no. Okay. So, it's two states. I can only have two states. Okay. So there's some nice marks to get you kind of started there. Nothing too hectic, Right, we'll move on to the next page. Now, what I'll do is I will we'll have to refer back to this, I'd say, a few times. Step through how the algorithm finds the name Zoe. So where's Zoe? Zoe's the third one in. So you're going to have to kind of, simulate what would happen to the computer as it goes through it. Okay. So let's try and, okay. So what's the first thing it does? I'll do it here and then I'll write it. Okay. So the first thing it does, okay, it's going to read in the names. It's going to read it. And then the first thing it does is the loop is going to check that it's false. Okay. And that the index is not equal to the length of the index is not equal to the length of the names, because if it is, then there's only one name and that's it. Okay, so that's the first thing. Okay, so what are we going to do? We're going to check the Boolean is false. Okay, so the loop is going to check that first. Okay, and we are not at end of list, because if it's at either of those two things, you're done. Okay, if it's not false, you're done. And if you've reached the end of the list and you haven't found it, you're done. So that's the first thing it does. Okay. What else are we going to do? We're going to compare the first element of the list to the input. Okay. Doesn't match. Increment the index by 1. Okay. Okay. What you do next? You do this again. Okay. So check the Boolean is false, etc. And compare second element of list to input. It doesn't match. Increment index by 1. Sorry about the writing, but you're getting the idea. Okay? I'm saying it as I'm writing it. Okay? Check the Boolean is false, etc., as in the first one. So these three are the same. Okay? Same. Okay? Check that the Boolean is false again. Compare third item to input. Okay? If they match, change found to true, break from loop, and print result. Okay, so to me, that's the kind of where you have to go on this. Okay, so you're doing 3 checks of the Boolean that it's false and that you're not at the end of the list. That happens each time in the loop. So let's check that. Yes. So that's what you're doing times 3. Okay. If the name is not equal, index it by 1. And you do that twice. And then the last time you do it, if it is, you change false, found true, you break the loop, and you print the result. Simple as that. What would the index what would be the index value after running the algorithm if the user entered a name that was not present in the loop? Okay, so this one's probably a tougher one now. So you're checking 0, 1, 2, 3, 4. It'll be 5, wouldn't it? Okay, sorry, it'll be 5 because it would loop through. Okay. What's the worst case complexity for this algorithm? Okay, so it's a linear algorithm. So the worst case complexity, so big O is n for a linear, isn't it? So the worst case scenario is you have to go through the entire list. Okay. So why explain your answer? Okay. This means that when searching for the item, the algorithm checks every element of the list. If the item is the last in the list, then it has to go through all elements, e.g., the number of things in the list equals n, where n is some natural number. So if there's a billion, it has to go through all a billion of them to find the last one. And of course, if it's not in the list, it still has to go through the billion of them to prove that it's not in it. So either way, that's what you're dealing with. Okay, so that's a tougher question now, and we've done a video on complexity. Okay, so just be aware of that. Okay. Aha. Speaking of which, binary search is generally regarded as a highly efficient algorithm. State one disadvantage of a binary search. Okay, so again, we talked about this. There is lots of advantages and the disadvantages to binary search. So it's the most obvious one. It's hard to code. Okay, it is hard to code. It uses processor resources. So there's a lot of thinking going on in the processor when it's doing this. Okay. It has to be ordered. Can't do a binary search unless it's an ordered list. Simple as that. Okay. And it's not really, you could also say it's not really suitable for shorter lists because it hasn't any advantage over a linear search for a short list. It's simple as that. You know, I can't really think of anything else there. Okay. Now the next bit. Okay, they give you a step through a binary. Okay, so step through how the binary search algorithm finds the integer 28 in the list L. So 28 is there. So how does it do it? Okay. Okay. So we're looking for 28. So 28 goes in. It has to be an ordered list. It already knows, the system already knows that it's an ordered list. So it looks at the middle number. So let's check how many numbers we have. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So usually you can create any rule you want on this, but usually it's if you have two middle numbers, you go with the lower one. Okay. So it checks the middle number. Okay. And if it's less than 28, okay, it's going to remove the values to the left of middle and the middle. So what you'll be left with is 28, 35, 41, and 50. Okay. Now, the new middle is going to be 35 because the middle is there. There's an even number. The middle is there, but we're just going to go one less. Okay. So the length of the list divided by 2 and then shift down. Okay. So it's going to be 35. Okay. So now we check the new middle is whatever, greater than 28. Okay. And remove or ignore, whichever way you want to think about it, all values to the right. Okay. So, okay, and you're left with 28 item found. Okay, so that's how easy it is. Okay, so find the middle. Okay, in this case, it's 18. If it's less than 28, move everything to the left, including that if it's less than 28. Okay, you've got your new set of numbers. Find the middle. The middle here is going to be 35. Okay, if it's greater than 28, you're going to remove it. Okay, 35 is greater than 28 plus everything to the right. It's gone. You've only got one number left. Check it. You've got it. Done. Okay. Probably tough. There's probably lots of ways you can do it. Right. Oh God, space for extra rough work. I don't like when I see that because people assume that they have to write stuff in there. What is the maximum number of comparison the binary search algorithm would need to make if the value to be searched for did not exceed the list item of 8? So if 8 is the maximum that you have to do, what's the maximum number of searches you need to do? Okay, so it's log to the base 2 of n, which is 3. Okay. You do it on your calculator, log to the base 2. Let's try and do it. Yeah, here it is. Log to the base 2 of 8 is 3. I don't know if you can see that. Now we talked about that the efficiency is log to the base 2 of n. Okay, so, and it was 3. We got it in 3. Happy days. Okay, part C. Right. Why is the study of algorithmic efficiency considered to be important in computer science? Okay. There's a long question. It's a lot of maths. So, or marks. So what are we talking about? What did we talk about earlier on? Why was the binary not good? Something to do with time, wasn't there? Okay. What else? Resources. And trying to think. Money. Right, so let's try and briefly talk about time, what we could put, okay? So efficiency, okay? You can get lag if it's slow, okay? You could lose money. if you can't find what you need quickly enough, let's say it's an algorithm that's searching through stocks for a particular up or down price or a particular, code, you could use money. And what else? Trying to find what other, personal impact. Personal impact. And what I mean by that is, let's say you're doing your Ticketmaster and you're checking for your for your 2 front row seats and that type of thing. Okay, so that won't help at all. Okay, so that's, you need to flesh that out, but there's where I'd be going on that one. The resources, I suppose that's another kind of key one. Okay, processor speed, number of threads that are being used, using up RAM, disk space, depending on it. Okay, it means that you're reserving space to do these searches that could be used to be doing other tasks. So you're using up resources there. So let me try and think now. Money. Yeah, here's another one. Cloud computing for the money. So companies buy cloud computing space from the likes of Amazon services, Microsoft services, and they charge per unit of server used. So the more you're using their cloud services to search through different algorithms to do things, the more money that they make off you, because you're using up their kind of, they're using up their servers. So obviously a more efficient algorithm will use less time, less server space, which means you're not having to charge them as much, and vice versa. They're not going to get as much money from you. So any of these kind of things will, I would try and put as much in there. You're probably better at kind of fleshing this out than I am, but that's where I'd be going on that one anyway. Right, question 14. Now, we have actually done this one in class, but listen, we'll go through it again very quickly, super quickly, just because it's very good. Explain the importance of Turing machines as computational tools. Okay, so listen, what you need to be mentioning here is they allow any computable problem that can be solved to be solved using a finite state machine. Okay, so it shows that computing is not limited by memory or processing powers like real world machines, because it's not. Because you can solve anything that is solvable and computable can be solved with this very simple formula. That's the reality of it. Okay, so you don't need flashy things. You could do it. It just take a very long time, but you could do it. So what about this? What's the significance of S2? S2 is the terminal state, the one that ceases, I suppose, the computation. So it's got that double circle on it. That means the computational state. The inputs, okay, state 1, if it puts in a 0, it comes out as a 0. Puts in a 1, comes out with a 1. And what it stays in state 1. However, you put in a blank, you come out with a 0, and the important bit, you move to state 2. Nice one, that one. Very nice one. Okay. Now, the next bit. Right, starting from there, move back to there. Okay, well, listen, this one looks a bit tougher than it actually is. So, you know, I wouldn't be too kind of worried about it. You're just following the kind of thing that you just literally wrote down for the man to give it a go at. So, where are we at? S1, they've done this one. Okay, this one is going to be a 1, a 0, and a blank, and we're still in state 1. Okay, and this one's going to be a 1, a 0, and a blank, and we're in state 1. And this one's going to be a 1, a 0, and a blank, and we're still in state 1. And this one's going to be a 1, a 0, and what are we looking at? 2, and another 0, isn't it? And we're in state 2. That's it. That's all it is. Right. In the mid-20th century, Turing carried out whatever he was doing. Bill Gates, humans should be worried. Okay. So it's a bit of a fluff piece. Okay, there's loads of space here, lads. So you really need you have to, and you see in the market scheme yourself, there's a lot of marks going here. Discuss the quotation above, focusing on the positive and negative effects. So that's the important thing. Discuss, okay, the quotation, okay, this one here, okay, focusing on the positive and negative effects. So that's your 3 kind of key building blocks for this that you have to look at, okay? So first of all, what I would do, I would list the positive and the negative, okay? Sorry, list the positive and the negative, okay? I don't know how many of each, maybe 2 or 3 of each, that's all you need, okay? Keep it very manageable, keep it very small, okay? You know, very, very simple statements, okay? You're better off going 2 or 3 positives that are very well thought out of than listing a whole ream of them and negatives and just not talking about them at all. The key here is quality, okay? Smaller amounts, but better quality, okay? So that'd be the first thing, list the stuff. That's thing number 1. Thing number 2, and then listen, if you're doing honors English or you're doing ordinary level English, you've done essays, so you know how to put an essay, okay? So again, you know, structure the essay, okay? Keep reflecting back, you know, statement that he's made, okay, the positive or negative, and then your conclusion, okay? That's what I would, okay? So if you're doing 3 positives, do, you know, your couple of lines on each positive, you know, referring them back to the statement each time, and then concluding the whole lot on your positive side, including the whole top on your negative side. And then if you have a little bit of space left, and you remember you have extra space at the end, feel free to then, you know, round up your argument one way or the other. Okay, so it's up to you. Like I could write an essay about this. I could give a talk about this. But you know, the reality is you have to, from the last 2 years, have got to have grasped the idea of artificial intelligence, the positive and negative effects it has on ethics. I did a whole thing on it. So you have to be able to kind of put that all into one go. There's a lot of marks going for that, lads. So I would put your money where your mouth is on that one. Okay, so where are we then? We are on, okay, this is a very interesting one. Okay, so this is a rock, paper, scissors game that you've been asked to design. Okay, and state whether you would use a staged or iterative development process for the project. Justify, well, obviously you're going to go with iterative because that's the one we've been buzzing. Agile, Scrum, Kanban, all that type of stuff. Okay, the first reason, well, listen, why do you use an iterative? Okay, allows you to allows you to catch errors, allows you to adapt to changing spec from the, you know, the employer, whoever, less bugs, more refinement, any of these things, okay? find more opportunities as you cycle through the iterative stages. Loads of waffle, but keep using those buzzwords. You know what I mean? Okay, that's what you really need to be doing there. Don't just leave it to one line. Those lines are there for a reason. You need to fill them. Okay. As a project manager, one of your main tasks will be to form a project team and assign roles and responsibilities. Identify 2 roles that would be appropriate for this project. Okay. So let's think about it. Remember when we were back at the, let's say, go with designer. Okay. And then let's go with maybe, tester. Because this is the type of stuff we've been doing. So user-centered design, 2 responsibilities, checking accessibility across different platforms, checking whether or not something is checking whether something is the accessible for different user types, for different deciding on what user interface is going to be best for. All that type of stuff is in the designers ones. 2 responsibilities there. Tester, we've done lots. We've done white box, black box, alpha, beta testing. Talk about all that there. Talk about it. Okay, that's what you need to be doing there. Okay, very easy marks there if you know what you're talking about. I've done a whole lot of videos on that, so there's no reason. Okay, what else we got here? Your project team has identified 2 user interfaces that they observed in the rock game. So here they have on the next page. Okay, so you've got this one, and then you've got looks like a very simplified one, and there's loads of space here. Compare the 2 interfaces. First of all, we have to compare the 2 interfaces in terms of applications. What does applications means? Applications means what it'll be used for, and functionality means how it actually works. So that's what you have to do there. So let's have a look at that very quickly and just see what we could actually buzzword around on this one. Okay. So let's have a look. I hope you can see this now. You'll see it if you're downloading it a bit better. But let's have a look quickly at interface 1. It's obviously looks more attractive. Okay, you've got a GUI, okay, graphical user interface. That's what it's built for. You've got pictures. You've got, JPEGs going on. It's a professional user-centered design. Okay, it's appealing to look at. It's interesting. What else? Let's say if it's a single screen view as opposed to 3 different views, that's the only thing I'm looking at there. I can see 3 different panels, but if it's a single, it's obviously designed for a tablet or something where you can rotate the monitor. Okay, it wouldn't be really good for a small unless you could rotate the screen around. Okay, it's got buttons. Okay, so which is quite good, of course. Buttons are very good for people with particular disabilities because they can move the mouse, or it'll be easy for them to just click when it gets close to it. Let's have a look at the user interface 2 then. Interface 2 is definitely basic. You'd wonder whether user interface 2 was the alpha, the white box, it was an earlier iteration of this one, because it seems to have the same functionality, but in a lot. They've only got 1 button, as you can see there, only 1 button, and it's it's what HTML uses. It's button selection. In other words, you select the button as opposed to press a button. And the 2 scores, it's very simple HTML. You can even see the way this looks like it could have been done using either, on a very simple, sandbox type of job. So it doesn't offer the additional features the other one does. It's the functionality of the system is very simple. It just does very basic things. You have 3 options, you get 1 output, and it just keeps the score with 1 play button. There's so many more options with the top one. It's doing a lot more. Now, with this, like when you pare them both down, you are just getting rock, paper, scissors. You are getting rock, paper, scissors. You are getting a score, and you are getting a play button or whatever. But this one just seems to be more integrated. Oh, there you go. Just a load of baloney, but I keep going back to the user interface things that we've talked about, and you will be grand on it. Now, provide 2 examples of how adaptive technology could be incorporated. Voice commands. Okay, Instead of pressing the button, you say rock, paper, scissors. Alexa, Siri, ask Google, they're all the same. Okay. Audio prompts for people with who are deaf or hard of hearing could tell you, well, this is the next one coming up. Again, this is just built for it being turned into a kind of an AI home AI type of system. Okay, so that's it. That's the paper done. Okay, it's a lot more than the other paper. It's a lot more chunky in terms of what you have to write. So you'd want to be pacing yourself, but then you get that chance in the exam to pace yourself and give it a go in a mock. Okay, thank you very much. Goodbye.